A pipe carrying water has a diameter of 3 centimeters at point 1 and 1 centimeter at point 2. And a pump is placed at point 1 to force the water at a speed of 2 meters per second. Now point 2 is a meter higher than point 1 and open to the atmosphere. So if we draw this pipe, it's going to look something like this. So over here we have a smaller diameter than the one over here. And point A on the pipe is effectively 1 meter lower than point 2. Okay, so this is 1 and this is 2. And on this side here, we have a pump. Let's just call that P. That's going to push the water out. And at point 2, we have an atmospheric pressure because the pipe is open to the atmosphere. And at point 1, we're going to have a pressure P1. And the question asks us for the gauge pressure at the pump. So what we do is simply apply Bernoulli's equation. So we have pressure 1 plus the kinetic energy term. So the pipe's carrying water, so 1/2 by the density by the speed at point 1 squared. Okay, so at point 1 we're given the speed is 2 meters per second, and then plus the potential energy term. So if we take our reference point to be at point 1, then the potential energy here is 0. And that's equal to the pressure at point 2, which is the atmospheric pressure, plus the kinetic energy at point 2, so 1/2 by the density of water by the speed at 2 squared, which is unknown, and plus the potential energy at point 2. So that would be the density of water multiplied by gravity, which I'm just going to take as 10 meters per second squared, and multiply by the height of 1 meter. Now by continuity, the flow rate is constant because the flow rate at 1 is the same as the flow rate at 2. And what we have is the diameter of the pipe at point 1 as 3 centimeters or 0.03 meters. So we have pi by the diameter squared on 4 is the area, multiplied by the speed at point 1, which is 2 meters per second, and that's equal to the area at point 2, which is pi by the diameter, so 1 centimeter or 0.01 meters squared on 4, and that's multiplied by the unknown speed at 2. So what we have is some cancellations, and if we calculate this out, well, what we get is V2 is 18 meters per second. And therefore, we can substitute V2 into this equation. Okay, so that will be 18 squared. And then solve for the gauge pressure. Okay, so what we're looking for is the gauge pressure, which is the pressure at 1 minus the atmospheric pressure. Okay, so if we calculate this out, what we get is the following result. So 170,000 pascals. And I'll see you in the next video.